Hi everyone, and this is Sandeep. You are watching Samyans Academy, and in this session, we are going to discuss about classification of element and periodicity properties, and we are going to discuss about the previous JEE question 2023. Ready? Let us start now. And the first question given that inert gases have positive electron gain enthalpy. Its correct order is okay. Inert gases are given, so you have to arrange in the increasing order of their electron affinity values. Okay. Now you see here helium, neon, argon, krypton, xenon. Okay, up to xenon is there. So down the group, electron affinity values, what happens? Increases or decreases? Decreases. And everyone remembers that neon has more electron affinity compared to the all other elements. So after neon, argon will come, next krypton, and next xenon will come. Then helium will come. Helium has least electron affinity compared to all other elements because of it has only one RB. Okay. What is electron gain enthalpy? Electron gain enthalpy means when you add the electron to the last shell, some atoms can liberate the energy or some atoms can absorb the energy. Okay. Means addition of electron. Simply we can say that addition of electron is called as electron affinity. So helium has only one orbit. Already it is fulfilled orbit, so it don't have any space to add the another electron. So it has less electron affinity compared to all other elements. So here which option is matching your here option? So you have to arrange in the increasing order. Then you make it reverse like this, not like this. You write in reverse order. Just you write in reverse order. Now you put the increasing order symbol. Okay. Then here order, which one is matching your answer? Helium, xenon, krypton, neon. Your answer C is matching. Okay, and remember in groups, second element has more electron affinity compared to the all other elements. Okay. So then move on to the next one. In the next question, which of the following represent the correct order of the metallic character of the given elements? So just the given elements you arrange in the correct order as per periodic table. So beryllium, second group, beryllium, magnesium. Okay. This silicon comes under in carbon group, carbon, silicon, germanium. So here it will come. In fourth group, the silicon will come. And the first group, hydrogen, lithium, sodium, potassium comes here. Okay. So this is arranged like this. All elements, given elements, you arrange like this. Okay. And now you tell across the period, metallic character decreases, non-metallic character increases. So down the group, metallic character increases as size increases. It can lose the electron very easily. Okay. Among all these elements, which one has the highest metallic means which one is having the highest size, means which one is having the more size, which one is having the more size? Yes, potassium is having more size. Then how do you know that the potassium is having the more size? Why? Because this is the which period? Second period, means it has only two orbits. Then sodium, third period. Potassium belongs to fourth period. So our element is potassium. So among given all the elements, potassium, beryllium, magnesium, and silicon. These are the given elements. Okay, what are the given elements? Here one is potassium, beryllium, magnesium, silicon. Okay, among all these elements, which one is having more in size? Potassium is having more in size, right? Then potassium has more metallic radius compared to the remaining elements. So which one is having less metallic character? Silicon. Why? Because across the period, metallic character decreases, non-metallic character increases. Now you see the silicon has less metallic character compared to the all other elements. Okay, silicon has to come first and potassium has to come last. And which one is the correct option here? Option A is matching here. You see, next which one will come? So metallic character. So down the group, beryllium to magnesium, metallic character increases, means beryllium has less metallic character than magnesium. Okay, so beryllium metallic character is lesser than magnesium. So your option A is matching. And this question given in JEE Mains 23. Next question. Now, the bond dissociation energy is highest for. The bond dissociation energy is highest for. Okay. So here they given fluorine, chlorine, bromine, and iodine. Okay. So bond dissociation energy. Before discussing this, now you see what is bond dissociation energy. Example, you take one fluorine. You take. Okay. Bond dissociation means the energy required to break the bond is called as bond dissociation energy. Okay. So now this chlorine. So which bond energy is more here? So let us discuss now. As the electron negativity values increases, as the electron negativity values increases, so the bond becomes shorter and the bond strength increases. Bond energy also increases. Means if electronegativity character increases, okay, bond energy also increases. So here what happens? So now you see among the all periodic elements, the fluorine has more more electronegativity compared to all other elements. But because of this, the fluorine has to exist more bond dissociation energy than chlorine, but it's not correct. Here chlorine has more bond dissociation energy compared to the fluorine. Why? Because of interelectronic repulsions, this fluorine has 3 electron pairs like this. Because of interelectronic repulsion force, the bond energy is lesser than chlorine. Okay, then fluorine, because in the smaller in size. Okay, because of interelectronic repulsions, the bond dissociation energy somewhat decreases as compared to the chlorine. Next, chlorine has more bond dissociation energy. Next electronegativity element is chlorine. Okay, so chlorine has more bond energy compared to the remaining molecule. So answer is your chlorine. As you move down the group from bromine to iodine, the electron negativity values decreases. Electronegativity value decreases. The bond energy value also decreases. Okay. So here chlorine has more bond more bond dissociation energy compared to the all other molecules. So answer is your chlorine. Answer is Cl2. Is it clear, everyone? Next question we have here. Choose the correct answers from the options given below. Match list 1 with list 2. In the list 1 they give an atomic number and list 2 they given the block of periodic table. Means the 37 atomic number having element belongs to which block? Is it belongs to P block or B block or F block, S block? You have to calculate. Then how do you calculate? If you know the group number with their atomic number, we can easily tell which comes under in which block. Okay, now you see 37. Otherwise, you do one thing. You just like this, you draw the Euler diagram like this. You fill the electrons. The last 37th electron enters into the which block, and that 37th element belongs to that block. Okay, so for example, you take 37 electron. 37 means, so 37, just you fill the electrons in their order. So 1s2, 2s2, 2p6, 1s2, 2s2, 2p6. Up to here 10 electrons are over, right? So next one, 3s2, 3s2, next 3s2. After 3s2 electron enters into 3p6, right? 3s2 after electron enters into 3p6. Up to here 8 electrons are over, 10 plus 8, 18. Next electron enters into the 4s2. Then 4s2 will come here. So 4s2, then 2 electrons. So up here 20 electrons are over, right? Like that you feel. Next 3d10 will come, right? 3d10. 3d10 means 20 plus 10 is, yes, 30. Up to here 30 electrons are over. Next electron enters into 4p6. So 4p6 means, so these 6 electrons, this is 36 electron over. Next, the next electron enters into s block, 5th orbit, 5s1 means the 37th electron enters into the s block, means the 37 atomic number having element belongs to s block, means you have to put here 4. Okay, now you see, and option C and D are matching with 4, A with 4. Now you check the other element and decide which one is the right answer. You take 52 next. You take C, 52, right? So 52, continue like this. So up to here 37 is over, right? 36 is over. So 36 up to here to This is 38, right? Now you check the 52 electron having number, right? So up here 38, right? 38 plus 10. 38 plus 10 is 48. So up to here 48 electrons are over, right? 48 plus 6. 48 plus 6 is 54, but we need only 52. 48 plus 4, right? So 5p4 means the 52 element, 52 atomic number having element belongs to which block? The last electron enters into the p block. That means the 52 electron having the element belongs to p block. P block means, yeah, and option C with the 1. So your answer D is matching, right? Option A with the 4. Any two you can compare. No need to compare all the 4, right? So from this we can conclude that the D is the right option. Okay. So 37 with 4 and 78 element belongs to D block. Okay. And the 65 atomic number atom belongs to which block it is? Last one is F block. F block is 3. Okay, so your answer D is matching. Like that you compare. Okay, if you don't know the atomic number or if you don't know the group idea, so then you just draw the Euler diagram and just fill the electron. The last electron enters into which block you see. Then you compare the 37 atom, the 37th electron enters into the S block means the atomic number 37 with the atomic number belongs to S block. Okay, and 52, the last 52nd electron enters into the p block means the last electron enters into the p block means the 52 atomic number having element belongs to which block? P block. Okay, in this way you have to check. Okay, is it clear? Make sure the correct increasing order of the ionic radius is. Also, these are the I think all are isoelectronic species, right? Isoelectronic species are having the same atomic number, means same number of electrons, right? Same number of electrons. Remember, if atom gains the electron, size increases. If atom lose the electron, size decreases. Okay, now you check the answer which one is the right answer here. Now you see all are having the 18 electrons or not? Calcium. Now you see calcium, you take calcium, it loses 2 electrons, right? Calcium atomic number is 20. 20 minus 2 is how much? 18. Okay, but it loses 2 electrons. Next, potassium atomic number is 19, but it loses 1 electron. 19 minus 1, again it has 18 electrons. Okay, so next one, Cl minus. So chlorine atomic number is 17. So it gains 1 electron. Minus means it gains 1 electron. 17 plus 1, it also having 18 electron. It gains 1 electron. And sulfur S2 minus, it gains 2 electrons. Okay, it gains 2 electrons. So this is also 18. Means this is the right option. Okay, so calcium loses 2 electrons, so its size decreases. Sulfur or sulfide gains 2 electrons, so it gains 2 electrons means size increases. It loses 2 electrons means size decreases. So which one is the right option? Option D is right option. Is it clear, everyone? Okay, then move on to the next question. Okay, and then in the next question, you have to this is neodymium 2 plus. It is that, so you have to give the correct electron configuration value, right? Electron configuration of neodymium 2 plus. Now neodymium atomic number, this is belongs to 4th, means F block group, F block, right? Neodymium atomic number is 60, right? Already you know that the common electron configuration of F block elements are n minus 2, F 1 to 14, right? And n minus 1, D 0 to 1, and this is ns2. This is a common electron configuration of F block elements, right? Neodymium nearest noble gas is helium, neon, argon, krypton. Next is xenon. So xenon atomic number is 54 and it is 36 and 18, and neon is 10 and helium is 2. Okay, so now which one is the nearest noble gas configuration to neodymium? Xenon. Okay, xenon number is 54. Okay, sorry, xenon number is 54, but neodymium is having how many electrons here? 60 electrons, right? 60 electrons. Then n minus 2 means neodymium, it is a F block element, and this is belongs to 6th period. Neodymium belongs to 6th period, right? Means here n value is 6. Okay, n value is 6, so 6 minus 2 is 4f, and next one is n minus 2, 5d will come, next 6s. Okay, then how do you fill the electron according to Moyle's diagram? The first electron enters into which orbit? After 4f, 5d will come. After 6s, 4f will come, next to 5d will come. Okay, now you see here. Just a minute. Then how to fill the electrons according to Moyle's diagram? Hang on a minute, just a minute. Just this Moyle's diagram, you keep it in your mind. This diagram you keep it in your mind. Now you see, according to this, now here 6s is there, 5d is there, 4f is there. Which one will come first? 6s will come first, right? Then electron enters into 6s2, right? So after 6s, the remaining electrons enters into 4f, right? 4f. Okay, so up to here 54 plus 2. 54 plus 2 is how much? 56. The remaining 4 electrons enters into F block. Okay, and the neodymium electron configuration is, we can write like this: xenon 4f4 6s2, right? But in this question, here we have to select for neodymium 2 plus electron configuration. 2 plus means after removal of 2 electrons from the last orbit, then what is its electron configuration? Now you see, after removal of 2 electrons from the last shell, the electron configuration becomes like this: 6s0. You need not to write 6s0, right? So neodymium 2 plus means you have to remove 2 electrons. After removal 2 electrons from the last orbit, the electron configuration becomes like this: xenon 4f14, right? So the last electron configuration of neodymium is your 4f4. This is your right option, that is B. So in this way you have to do. Is it clear, everyone? Okay, move on to the next question. Okay, so in this question, now see, this is the next question. Given below are the two statements. One is labeled as assertion and the other is labeled as rejection. Assertion A: the first ionization enthalpy of 3D series elements is more than that of group 2 metals. Okay. Reason R: in 3D series of elements, successive filling of d orbitals takes place. In the light of the above statements, choose the correct answer from the option given below. Now, in this question, 3D series, what are the 3D elements? Can you guess? Scandium, titanium, vanadium, chromium, like this. All these are the 3D elements. Manganese, iron, cobalt, nickel, copper, zinc. Iron, cobalt, nickel, copper, zinc. So these are the 3D series elements. You compare with first ionization elements of 3D series of elements more than that of group 2 metals. What are the group 2 metals? Beryllium, magnesium, calcium, strontium, barium, radium. Group 2 metal means all are having NH2 electron configuration, right? The elements with having fulfilled configuration or off-filled configuration has more ionization energy compared to the all other elements. Yes or no? So these are the second group element configuration NS2. The common electron configuration of second group elements are NS2. It has more ionization energy compared to all other elements, but it is given wrong here. The first ionization enthalpy of 3D series element is more than they give, but this is not correct. And this NS2, the second group elements are having the common electron configuration in NS2. This is fulfilled electron configuration, and these elements are having the more ionization energy compared to these elements. Okay, so the first statement is a false statement, And the next statement, so first statement is false, means here next statement R is true. Okay, your option C is matching. In the light of the above statements, choose the correct answers from the option given below. And reason you read here, in 3D series of elements, the successive filling of d orbital takes place. Yes. Scandium, successive filling of d orbitals means what is the common electron configuration of scandium? So argon, this is scandium is 21, right? So that it will become D1, and titanium 22, D2, D3. Okay, like that electrons we have to fill. This is D5, D5, D6, D7, D8, D10, D10. Okay, like that the successive filling of d orbital takes place in the 3D element. This is the right state. Okay, so your option or the assertion A is false, but reason is true, right? So you have to select the answer C here. So next question. Okay, which of the following elements have off-filled f orbital in the ground state? And also they given here the atomic number also 62, 63, 65, 64, 61 also they given. So we have to choose the correct answer from the option given below. So which one is correct answer? Okay, so before that you just this is the samarium 62. Already just now we discussed the neodymium. Neodymium electron configuration, that is the 60, atomic number of neodymium is 60. Then the electron configuration of neodymium is 4f4, 6s2. Okay, based on this you have to fill the electrons, right? Now you see this is samarium 62. Samarium 62. The 62, how we can fill this? Xenon up to here 60, right? 62 means you have to add 2 electrons in the f block, that is 4f6, 6s2. This is samarium. Next one is terbium. Which of the following elements have off-filled f orbital? Off-filled f orbital means 4f7. 4f7 electron configuration we need to select, right? Next one is, you see the terbium. So terbium is, now you see if 2 electrons when join here, what happens? You see if 2 electrons, not 2 electrons is not possible, and for a off-filled configuration this is not correct configuration. Now you see 63. Now you see 63 is there. Europium. Now you tell europium has electron configuration is 63, right? Now you fill the electron. Xenon. This is off-filled configuration. You see 4f7 is coming. Okay, so the B1 is the right option. So B in option A is also there, and B in option C also there. Okay, in so in between A and C, you have to select the right option here. Okay, 63. 4f has how many orbitals? F block has 7 orbitals, right? 7 orbitals means off-filled configuration is 4f7. Is it clear, everyone? Right. So next one is terbium. You see the terbium. Terbium electron configuration is, what is the terbium electron configuration? 65. Electron atomic number is 65. 65 means you add 2 electrons here. So xenon. So up to here 63, right? This is 65 means you have to add 2 more electrons. So 4f7, 8, 9. So this is not the off-filled configuration. So this is not the correct option. Next you see the 64. 64 is the gadolinium, xenon, 4f8. Next 6s2 is coming. To get the off-filled configuration, 1 electron jump into the d subshell or d orbital. Then gadolinium electron configuration becomes like this. Xenon, 1 electron jump to here to get the stable configuration. So 4f7, 5d1, 6s2. This is a gadolinium electron configuration. Okay, gadolinium also having the off-filled f block configuration. Okay, so answer is here gadolinium also, means gadolinium here it is in option D, it is there. So option D and option B and D is the right answer. So your answer A is matching, right? So your answer A is matching. B and D is the right option. Okay, so in this way you have to select. Okay, is it clear, everyone? Move on to the next question. For electron gain enthalpies of element denoted delta H, The incorrect option is, already you know that chlorine. In fluorine, which one is having more electron affinity value? Fluorine has more electron affinity value compared to the fluorine, right? So now you see, for electron gain enthalpy of the element denoted with the delta H, the incorrect option you have to select. Incorrect option you have to select. Okay, so this is electron gain enthalpy. Now you tell, in fluorine, which has more electron affinity? Fluorine has more electron affinity. That is already you know that. Fluorine has more electron affinity than fluorine. Means in every group, the second element has more electron affinity than first element. Okay, and delta H of fluorine is greater than delta delta H F. Okay, this chlorine has more electron affinity than fluorine, but it is given in the reverse order. So this is wrong option. Next one is you have to select the incorrect option. This is only incorrect option. Now you see sulfur, oxygen, sulfur, selenium, tellurium, polonium, like that it will come. Tellurium, polonium also there. Oxygen, sulfur, selenium, tellurium, polonium, and these elements belongs to oxygen group, right? That is sixth group. In this, sulfur has more electron affinity compared to the all other elements, right? Then sulfur electron affinity is more than oxygen. Next selenium will come, next tellurium will come, next polonium will come. Okay, but the tellurium has more electron affinity than polonium. I think it is which the for electron gain enthalpy I have to select the correct option only, not the incorrect. And this is also not correct. Now you see selenium, sulfur. Now you see sulfur has more electron affinity than selenium. So this is the correct order. Okay, this is correct order. But you have to write the question, not the incorrect. You have to select the correct option, not the incorrect. For electron gain enthalpy of the elements denoted as delta H, you have to select the correct option here. Which one is the correct option, not incorrect. Why? Because I will tell you. Next, iodine astatine. Iodine astatine comes under which group? Fluorine group, right? Fluorine, bromine, iodine, astatine. Now you tell, fluorine has more electron affinity than remaining elements. Okay, fluorine has more electron affinity than remaining elements. Next fluorine will come, next bromine will come, next iodine, next astatine. Astatine has less electron affinity than iodine, but it is given iodine is having less than astatine. It is not correct. Okay, it is not correct. Okay, you should see the order. Down the group electron affinity decreases, but it is given in the increasing order. So this is not correct option. Next to tellurium, polonium, you see. Polonium has less electron affinity. Then down the group, whatever the polonium comes last, right? The down the group electron affinity has to decreases, but it is increasing in order given, right? So tellurium has more electron affinity than polonium, but it is given in the reverse order. So this is also not correct. But which one is correct option among these four? Second option is the correct. Okay, so option B is the right answer. Is it clear, everyone? Okay, then move on to the next question. Yeah. So in this question, which one of the following element will remain as liquid inside pure boiling water? Yes, the answer is gallium. Okay, gallium is a liquid metal. Which one of the following elements will remain as liquid inside pure boiling water? That is gallium. Gallium is liquid metal. Remember. Okay, move on to the next question. Next, group 13 elements reacts with oxygen in amorphous form to form oxides of type M2O3. So, which among the following is the most basic oxide? So, these are the same group elements oxide: boron, aluminium, gallium, indium, thallium. So now you see, down the group you are in boron. After boron, which one will come? Aluminium. Aluminium already know that aluminium oxide is the amphoteric oxide. Okay, and down the group the metallic nature increases. The metallic nature increases, means basic character of the oxides increases, right? Boron, aluminium. Next one, gallium will come. Next, indium will come. Okay, next one is thallium will come. Okay, so in this one, group 13 elements react with oxygen in amorphous form to form oxides of type M2O3. Which among the following is the most basic oxide. Okay, now you tell. Down the group as electronegativity values decreases, right? Metallic character increases. If metallic character increases, if metallic oxides nature becomes basic in nature. Okay, so down the group, what happens? Metallic character increases. Yes or no? Metallic character increases, and this is a non-metal oxide. This is non-metal oxide. Non-metal oxides are acidic in nature, and this is amphoteric oxide. Aluminium Al2O3 is a amphoteric oxide. It has dual nature. It can act as acid as well as base. So as you move down the group, the basic character increases, acidic character decreases. So which one will come the last? Tellurium oxide. Okay, Tl2O3. So this is a basic oxide. Okay, so option C is your match. Tl2O3. Okay, so down the group, what happens? The metallic character increases, the basic character of the oxides also increases. Okay, so aluminium oxide is a amphoteric nature, amphoteric oxide. It is amphoteric, it is also amphoteric, and down the group, which one is having the more basic in nature? Thallium oxide. Okay, so the answer is C. Next question. The correct order of electronegativity for given element is. Okay. So here the given the fourth group elements, I think carbon, silicon, no, not for fourth group. These are the mixing of all the elements, right? So now you see what are the elements they are given. You arrange in the correct order, like periodic table order, right? So just you arrange these in periodic table order. Right. The correct order of electronegativity for given element is. Now you see here, get the given carbon, right? After carbon, nitrogen will come, right? Carbon, nitrogen. Next, phosphorus comes here. Carbon, nitrogen. After nitrogen, oxygen. Oxygen group element is not there. Next one is oxygen. After oxygen, fluorine will come. Fluorine, bromine, and fluorine, bromine, iodine, acid. Like this, you arrange all the elements. Okay. So already this is the carbon. This element given, right? So next phosphorus also given, next bromine given, next astatine given. Okay, so among all these elements, which one has more in electron affinity? Sorry, electronegativity, not electron affinity, electronegativity. Remember, for electronegativity, you have to select for the smaller size atom. Okay, which one is having smaller in size compared to all other elements? Carbon. Then carbon has more electronegativity character than remaining. Next carbon, which one has more in size? Phosphorus. Next bromine. Next acetylene. Down the group, what happens? Size increases. Right? As the size increases, electronegativity character decreases. In between carbon and bromine, now you see seventh group elements are having more electron affinity. Seventh group elements are having more electron affinity compared to all others, I think. So now you see carbon, phosphorus, bromine, acetylene. So being in seventh group, the bromine has more electron affinity than carbon. Okay, so next here you have to write here. So which one is right option here? So bromine has more electron affinity than carbon. Okay, so being in seventh group, the astatine has more electron affinity than, which one is right option? Yeah, that is 4. Bromine has more electron affinity than carbon, and astatine has more electron affinity than phosphorus. Why? Because being in seventh group elements are more electronegative elements. Fluorine has most electronegative element. The it has electron negativity value is 4. Okay, down the group electron negativity values decreases. When compared with the carbon, bromine has more electronegativity. So bromine has more electronegativity than carbon. When compared with the phosphorus, astatine has more electronegativity than phosphorus. Right? So this is the right option. So your option B is matched. Hey, నోరు మూసుకోరా ఇప్పుడు చూడు వస్తున్నా right. So given below are two statements. One is labeled as assertion A and other is labeled as reason R. Assertion A given that the energy required to form magnesium 2+ from magnesium is much higher than that required to produce magnesium plus, and reason are given here. Magnesium 2 plus is smaller ion and carry more charge than magnesium plus. In the light of the above statements, choose the correct answer from the options given below. Now you are given that. So what is the atomic number of the magnesium? Magnesium atomic number is 12. Okay, so the electron configuration of magnesium is 1s2, 2s2, 2p6 and 3s2. So in the statement given that the energy required to form magnesium 2 plus from magnesium is required much higher energy that required to produce magnesium plus. Okay, from the magnesium, after removal of 2 electrons, so you just remove the 2 electrons, it will become magnesium 2 plus. Means removal of 1 electron requires less energy, removal of 2 electrons require more energy. Why? Because as you remove the electrons, what happens? The size decreases. As size decreases, the energy required for next electron is more to pull the electron from the last shell. Okay, when you remove the electron from the last shell, the size of the atom decreases, means it will become ion. And when you remove one more electron from the next size, one more electron from that ion, then it requires higher energy compared to the last one. Okay, for example, now you see this is the magnesium. How it will become magnesium 2 plus? After removal of 2 electrons. After removal of 1 electron, it will become 3s1. After removal of 2 electron, it will become 3s2. As you remove the electron, the size of the ion decreases. As size of the ion decreases, the attraction forces increases. We need more energy to remove the next electron. Means magnesium to magnesium 2 plus for removal of 2 electrons, it requires more energy as compared with the magnesium plus. Now you see in between magnesium plus will come. After removal of 1 electron, the 3s1 will come, right? So as the removal of electron increases, the size decreases, energy increases. Okay, means this given statement is correct. Okay, so the energy of required to form magnesium 2 plus from magnesium requires much higher energy than required to produce magnesium plus. Then how will you produce the magnesium to magnesium plus? For this you require only 1 electron, right? So after removal of 1 electron, from the magnesium, so it will become magnesium plus. It requires less energy. Now when you remove the 2 electrons directly from the magnesium, it requires higher energy. So it will become magnesium 2 plus. Okay, for removal of 1 electron require less energy, for removal of 2 electron require more energy. Okay, why? Because when you remove more number of electrons, the size decreases, stability increases. To remove the electron, we need more energy, means ionization energy values also increases. Okay, magnesium to magnesium 2 plus require more energy, magnesium to magnesium plus require less energy compared to this one. So this is a reason assertion A is correct and reason R also correct. Why? Because magnesium 2 plus is a smaller ion, and as the charge increases, the charge increases. As the charge increases on the atom. Okay, magnesium 2 plus magnesium plus to magnesium 2 plus charge increases, means the ion will become small. Okay, where the smaller the ion, it carries the more the energy than magnesium plus. And assertion region both are correct, and both A and R are true, and R is the correct explanation of A. Is it clear, everyone? Okay, move on to the next question. And the correct order of metallic character is, okay, metallic character, these are belongs to all same group or not? No, this not belongs to same group elements. Now you see, beryllium, calcium belongs to second group element. Beryllium, magnesium, calcium, and these belongs to second group elements. And next lithium, sodium, potassium. Okay, now you tell which one has more metallic character. First A group elements are more metallic character than second A group element. Okay, so metallic character down the group, what happened? Increases. Now potassium, across the period, metallic character decreases. Now down the group, first potassium to calcium, metallic character increases or decreases? Potassium to calcium, I am asking potassium to calcium, metallic character, what happened? Decreases. Okay, potassium has more metallic character compared to all other elements. So here given elements are, what are the given elements here? Potassium, next one is beryllium, next one is calcium. Then potassium has more metallic character. Okay, in between beryllium and calcium, which one has more metallic character? Down the group, metallic character increases, means calcium has more metallic character than beryllium. Calcium has more metallic character than beryllium. So which one is right option here? So which one is matching? Potassium, calcium, beryllium. So answer C is matching. Is it clear, everyone? Okay, so move on to the next question. Okay, and the next question, for compound having the formula GaLCl4, the correct option from the following is: chlorine forms bond with both aluminum and gallium in GaLCl4. Gallium is coordinated with the chlorine in GaLCl4. Gallium is more electronegativity than aluminum and is present as cationic part of the salt. Oxidation state of gallium in the GaLCl4 is +3. Okay, so which one is right option? Now you see, option C is right answer. So why? Because compared to the boron to aluminum, aluminum to gallium, electronegativity has to decrease, but here exception case is there. So gallium has more electronegativity than aluminum. So because of this, gallium exists in cationic part of this salt, and Al aluminum form the bond with chlorines like this. Okay, AlCl4, and it carries some minus charge. Okay, this is the cationic part. Gallium is more electric to the aluminum, and the gallium is present as cationic part like this. So in the part of the salt, their answer C is matching. Okay, so move on to the. For elements boron, carbon, nitrogen, lithium, beryllium, oxygen and fluorine, the correct order of first ionization enthalpy is. Now given elements you arrange like this: boron, carbon, nitrogen, oxygen, fluorine. Okay, so across the period what happened? Ionization energy values increases. Why? Because across the period size decreases, the energy required to remove an electron also increases. Okay, across the period size decreases, ionization energy values increases, but exception cases are there. So boron, hydrogen, helium, lithium, beryllium, boron. So boron electron configuration is 1s2. What is the atomic number of the boron? 5. 1s2, 2s2 and 2p1 will come here. So this is 2p2 and this is 2p3 and 2p4 and this is 2p5. So already you know that because of fulfilled configuration or off-filled, because of off-filled configuration, this nitrogen has more ionization energy than oxygen. Nitrogen has more ionization energy than oxygen. So nitrogen will come here. So this nitrogen will come here. So nitrogen has more ionization energy than oxygen. And one more electron also there. Lithium, beryllium also you take here. Lithium, beryllium. So lithium beryllium configuration is 1s2, 2s2, and lithium configuration is 1s2, 2s1. Okay, because of fulfilled configuration, because of 2s2 is the fulfilled configuration, because of this the beryllium has more ionization energy than boron. Okay, so beryllium comes after boron, right? So next you arrange in the order. Lithium will come first. After lithium, which one will come? Lithium. After lithium, boron will come. So boron after boron, beryllium, next carbon, next oxygen, next nitrogen, next fluorine. Okay, so which one is the right option here? Answer D is matching. So what is the right option here? Answer D is matching. Is it clear, everyone? Which of the following statements are not correct? The electron gain enthalpy of fluorine is more negative than that of chlorine. So it is not correct. Electron affinity of chlorine is more than fluorine. It is given in the reverse order. This is not correct statement. And next one, the ionization enthalpy decreases in a group of periodic table. Yes, is it correct or not? Yes, it is correct. Ionization energy down the group decreases, across the period increases. Next, the electronegativity of an atom depends upon the atom bonded to it. No, it is not correct. The electronegativity of an atom depends on the size of the atom. Okay, if size decreases, electronegativity values increases. Next, this C also not correct. It is not depends upon the bonded atom bonded to it. Okay, it depends on size of the atom. And next, Al2O3 is a Al2O3 and NO are the examples of amphoteric oxide. Yes, Al2O3 is amphoteric, but NO is neutral oxide. NO is not amphoteric oxide; it is neutral oxide. So this is also not correct. Okay, so which are the statements are not correct here? A is not correct, and C also not correct, and D also not correct. So A, C, D. So your option A is matching. Okay, move on to the next question. Identify the correct order of standard enthalpy of formation of sodium halides. Okay, means sodium iodide to sodium fluoride. So how the enthalpy, standard enthalpy of formation of sodium means if cation is formed by anion, okay, because of opposite in charges, and when it is formed as a solid ionic solid salt, okay, it liberates some energy. Okay, the amount of liberation of energy depends on size of the atom. Okay, as the as the ion size decreases, as ion size increases, standard formation of enthalpy increases. Means the size of an anion is inversely proportional to standard enthalpy formation. Standard enthalpy of formation. Okay, depends on this, you have to select the right answer. The size of anion is inversely proportional to standard enthalpy of formation. Okay, if size of anion decreases, the standard enthalpy formation increases. Based on that, you have to select the answer. Means the sodium fluoride has more standard enthalpy formation than sodium chloride. Okay, then why? Because fluorine, chlorine, bromine, iodine. As the anion size increases, the enthalpy formation decreases. Means now you see the sodium iodide has less energy than sodium fluoride. So which one is right option here? Answer D is right option. Right? The size of anion is inversely proportional to standard heat of formation. Standard enthalpy formation. Standard enthalpy of formation depends on size of anion. Fluorine size is less. That means it has more enthalpy of formation. Iodine size is more, but that's why it has less standard enthalpy of formation. Okay, so next one, the number of molecules from the following which contain only two lone pair of electrons is. So which contains two lone pair of electrons? Okay, for that you need some chemical bonding, right? Chemical bonding, this is not related to periodic table, but it related to chemical bonding also. And now you see oxygen belongs to which group? As per chemical bonding, oxygen belongs to sixth group. You put 6 electrons, 1 2 3 4 5 6. Here we have two hydrogens, H2O. H2O means two hydrogens bonded with 2 electrons of the oxygen. Means H2O has how many lone pairs now? H2O has 2 lone pairs. Oxygen has 2 lone pairs. Okay, so next to nitrogen. Next to carbon monoxide, xenon tetrafluoride. So nitrogen I will tell later. So now we tell about carbon monoxide. Okay, carbon monoxide. So carbon bonded with triple bond with oxygen. So nitrogen also has triple bond with 2 ends. And next is xenon tetrafluoride. Xenon belongs to which group? Xenon belongs to 8th group. So put 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. So here electrons of fluorine, 4 electrons of fluorine bonded with 4 electrons of the xenon. So here we have 2 lone pairs. This is also having 2 lone pairs. Next to carbon dioxide and fluorine also there. Carbon dioxide. Carbon belongs to which group? 4th group. Okay, you put 4 electrons. One oxygen takes 2 electrons. Then like this you will get a linear molecule it will come. Is there any lone pair on carbon atom? No. So this is as 0 lone pair. And next to fluorine. Fluorine bonded with fluorine like this. So fluorine has 3 electron pairs like this. And then how it will come? 3 plus 3, total 6 electron pairs are there. Fluorine belongs to which group? Yes. Fluorine belongs to 7th group. Put 7 electrons. 1, 2, 3, 4, 5, 6, 7. Okay. So how many fluorine atoms are there? Only one fluorine atom bonded with fluorine atom of another electron. Like that, one fluorine has like that 3 electron pairs. Another fluorine also has same like that 3 electron pairs. It has total how many electron pairs are there? 6 electron pairs are there. Okay. Then nitrogen form another nitrogen with 3 bonds. Means nitrogen belongs to which group? Nitrogen belongs to 5th group. put 5 electrons, 1, 2, 3, 4, 5. But here one nitrogen bonded with 3 electrons of another nitrogen. Okay, one electron bonded with 3 electrons of another nitrogen, means one nitrogen form bond with 3 electrons of another nitrogen. So nitrogen has here how many lone pairs? One lone pair. But here we have one lone pair. This nitrogen also has one more lone pair, like this. Okay. So it has two lone pairs now. So two lone pairs. Two lone pairs. Next one, carbon monoxide you see. Carbon monoxide. So carbon belongs to which group? Yes, carbon. Here carbon monoxide you see. Carbon monoxide has two electron pairs. Okay, two lone pairs. Sorry, two lone pairs. Carbon monoxide also. Already you know that ammonia, because they are in pyramidal shape, nitrogen belongs to nitrogen. NH3 you see here. NH3. Nitrogen cover avutundi. Okay, so nitrogen belongs to which group? Fifth group, right? So this 3 hydrogens bonded with 3 electrons of the nitrogen. So nitrogen has here one lone pair. So this is having only one lone pair. Ammonia. Next NO. NO molecule you see here. NO. Remember, nitrogen has every time it has only one lone pair. Then oxygen every time it has two lone pair. Okay, wherever that oxygen comes. Okay. So, but here oxygen has one lone pair. Here carbon also has one lone pair. Okay. So CO has two lone pairs, and nitrogen, nitric oxide is having three lone pairs like this. Okay. Now, how many molecules are having two lone pairs? Okay. Now you tell how many molecules are having two lone pairs. Yes. Now you see H2O is having two lone pairs. Nitrogen also has two lone pairs. Xenon tetrafluoride also has two lone pairs. And the next one is carbon dioxide, no. Nitric oxide, NO, yes. NO has three lone pairs. Ammonia has one lone pair. Carbon monoxide, now this one. Carbon monoxide also has two lone pairs. Okay. And this ammonia has only one lone pair. Nitric oxide has three lone pairs. Carbon dioxide, there is no lone pair. Fluorine has 6 lone pairs. Okay, like that you have to arrange. So among all these molecules, how many molecules are having two lone pair of electrons? Only 4. Those are H2O, water molecule, nitrogen molecule, carbon monoxide, and xenon tetrafluoride. Okay, so this is the explanation about this. Okay, now move on to the next question. Metals generally melt at very high temperature. Among the following, the metal with the highest melting point will be. So which one is highest melting point? Before going to this, the mercury is the liquid metal. Mercury also liquid metal. Gallium also liquid metal. Cesium also liquid metal. So which one is solid metal? Silver is the solid metal. It has high melting point. Okay, here option B is the right option. Okay. And the next one is the correct order of electron gain enthalpy of chlorine, fluorine, tellurium, and polonium. Already you know that among the all periodic elements, chlorine has most electron affinity element. Means chlorine has to come last year. So among all these options, chlorine has more electron affinity. Option is here B. Next, fluorine will come. So in tellurium, polonium, so oxygen, sulfur, selenium, tellurium, polonium. Okay, so down the group, what happened? Electron affinity decreases. Means tellurium has more electron affinity than polonium. So which option is matching here? Answer B is matching. Okay, clear? And the next question, which of the following elements is considered as metalloid? Already you know that down the group, the metallic nature increases. Across the period, non-metallic character increases. Scandium is a D block metal, and carbon, silicon, germanium, tin, lead. This is the fourth group element, and lead comes in last of the group, right? So metallic character increases. Next, this bismuth, nitrogen, phosphorus, arsenic, antimony, bismuth. This is the dead end element. so it has metallic character. Then the left one is only tellurium. Tellurium has metalloid. Okay, so where it will come tellurium? Oxygen, sulfur, selenium, tellurium. These two are metalloid, selenium and tellurium. Here tellurium is metalloid. Okay, so down the group, metallic character increases from non-metal, metalloid and metal, like that it will fall. Okay, thank you for watching. Please subscribe Samyans Academy. Thank you. Have a nice day. Bye.